Welcome to our smart classroom. Today we'll explore molecular structures. Let's look at these models to understand the concepts better.
All right, let's talk about the number that organizes, well, the entire atomic world. So, every electron has a unique address, and we're going to start with the most important part.
To completely describe the position and behavior of an electron in an atom, we use quantum numbers. Quantum numbers give
Is the star of our show, the principal quantum number, or just n.
Okay, think of it like this. If an atom is an apartment building, n is just the floor number.
The rules for these floors are super simple. They're just positive whole numbers starting from 1.
So, why does the floor number matter? Well, it tells us two absolutely crucial things.
First up, energy. The higher the floor, the more energy that electron is packing. Which means electrons on those higher floors are farther from the nucleus and easier to knock away.
And that brings us to the second point, size. Higher floors mean a bigger electron cloud.
But wait, there's more. Every floor in this building has its own set of building codes.
The principal quantum number, represented by n, tells us the main energy level or shell of an electron in an atom.
Trons. And it all comes down to this simple formula. It's the key to knowing how many electrons can fit.
Now, this isn't just some abstract theory. This number literally builds the world around us.
Ever wonder why the periodic table is shaped the way it is? Yep, it's because of n.
And even explains why elements glow with different colors. Think fireworks or neon signs. It happens through something called a quantum leap. An electron literally jumps between floors. And the bigger the fall, the more energetic and colorful the light that's given off. So let's recap. N is the floor number. It tells us about energy, size, and capacity.
We found the floor, sure, but what about the apartment, the room, and even the person inside?
The maximum number of electrons that can occupy a shell is given by the formula 2n squared. For n equals 1, the shell holds 2 electrons.
Notice how the orbit radius increases as n increases. This directly correlates with the rise in energy shown here.
The radius of an orbit in the Bohr model is given by the formula r sub n equals n squared a naught. Here, a naught is 0.8.
Although Bohr's model was revolutionary, it has certain limitations. First, it works only for hydrogen and hydrogen.